Christopher Anderson, for those that want to hear the full name, knows that he knows the DIT inside out and can basically tell you everything about how it works. But this topic is not about the Active Directory DIT, it's about PKI. And what I love that Chris and I have also been, let's say, parallel MVPs in the time that we had that lovely title. But what I never reached, and this is pretty amazing, last year he was rewarded the most valuable researcher, the MVR award by Microsoft. So that's pretty cool too, for the stuff that you found and that you've of course notified Microsoft about, instead of, you know, selling 0 days to the dark side. Yeah, that's what other researchers do. So this is absolutely a cool thing. Thanks for doing that and helping to protect us. And now listening in what Chris has to say on PKI. Chris.
Okay, thank you, Guido. So yes, when your enterprise PKI becomes one of your enemies. So I got a little introduction there already, but my name is Christopher Andersson. I'm from Sweden. I've been aboard Microsoft MP multiple of times between 2004 and 2011. I was recently also awarded Microsoft Valuable Researcher for the type of things I'm gonna show here, and that has to do with Entra ID and certificate-based authentication. And yeah, as Guido mentioned, I usually go pretty deep dive when it comes to Active Directory inside the database and the DSDIT. I also did a couple of HIPS conference backs. I did a talk on replication APIs and so on. But today I'm only going to mention one API, so we're not going that deep, but we're still going deep. So, do you have enterprise CA, or you have some kind of CA in your environment? Who many has a CA that is trusted to authenticate against AD or Entra ID today? Okay. So, how was that kind of PKI established? Was it established under the circumstances that you first were establishing a certificate policy, a certificate practice statement, and you had a key ceremony and you put the key in an HSM? Or was it something that needed a certificate and that CA just more got next finished installed and then it's, yeah, around there? So you can be trusted for authentication against AD in multiple ways. So either the CA is explicitly trusted to perform authentication against AD, and that's something that's called that you're trusted in NT-out. So that is an object in the configuration NC, in services and public key services, and you have an object that's called NT-out there, and you can trust the list of CAs. You could also be explicitly mapped, and that's when you use the AltSec ID attribute, where you put in on a user object and you say that this certificate actually belongs to this user, and that CA of course has to be trusted on your KDCs and domain controller chain-wise. You need to be able to verify the chain there. So both the NT-out and AltSec ID goes through the KDC, something that's called PKI in it. And there is also S-channel that can be used. So for example, by network policy service, if you authenticate with certificate against IAS, ADFS, and so on. So those are basically the ways that you can be trusted to authenticate with CERT against AD. And Microsoft recently, not so recently though, but they moved the dates for something that's called strong certificate binding enforcement. That means that to be able to authenticate, there are new rules that says that you need to have the SID in the certificate as an extension, or you need to do AltSec ID mapping on the accounts. And that's the ones that I highlighted in blue there actually applies to that. So let's have a look at NT-out. Yep, as I said, that is stored in an attribute that's called CA certificate, can contain multiple CAs. If you install ADCS, like an enterprise CA, it gets automatically trusted there. So it's getting in there. And what's happened if you have the group policy CSC for auto enrollment is that certificates, all the certificates from that attribute is getting pulled down to the registry of all the domain joined workstations on that forest. And that's how they're trusted. So who validates against NT-out? So yeah, as I mentioned, PKI init, KDC if you're authenticating with smart card or YubiKey, basically all kind of certificate-based authentication against the KDC, LDAP start TLS, MPS, IS, and also ADFS if you're still using ADFS. And how is this check performed that the CA, that the certificate actually comes from a CA that is trusted in NT-out? So, well, the most obvious maybe would be that, well, just do an LDAP query and see if is this CA really trusted to perform authentication against Active Directory, but that's not how it works. So everything that's actually do this kind of validation uses an API that's called crypt32 DLL, and there's a function that's called cert verify certificate chain policy, which you can call with a specific flag that's called cert chain policy NT-out. And in addition to checking that the certificate chain is valid, it hasn't been revoked and so on, it also checks that the CA is trusted in NT-out. But how is it doing that? Locally on each computer. It never goes out to AD and asks that. Not even the KDC asks AD itself. It actually looks down in the registry. So if you have a local member server and you put your own CA in here, then you can get in. But of course, you need to be local admin to write that reg key, so that is not so fun as it should be. But you could take an RODC, for example. If you would do this on an RODC, you get in on the RODC as an administrator if you want, but because of Kerberos key separation, you cannot walk away with that key and present it to a read-write DC, because it would just say that, well, this key is from RDC. I showed this exact same slide when the HIP conference was virtual because of the pandemic, so it was all streamed. And what I showed then was that if you have certificate templates that has something that's called supply in the request, then you can utilize that to put whatever you want in there, because you can control the subject. And the bad thing is, if you have the possibility to enroll on a such template, is like you could actually put the UPN of an account in there, and then you will actually compromise the forest, because you will become the one which UPN you specify in that request. So that's pretty much game over if you have the ability to enroll the web server template, for example, from just a tier 2 guy here, just a client guy, but could also be a tier 1 guy. So I think we will have a look how that works. And something special about the web server template would be that it only by default has this server authentication EKU, and client authentication is required to be accepted by the KDC. But some smart guys come up with that Microsoft has its own extension that's called application policies. And if you utilize a version 1 template, you can actually supply the EKU yourself in the request. So you can actually make the web server template also adding client authentication, making that working. So let's request a certificate. This is a CA that's trusted NT-out. And we do some magic here to actually inject the client authentication EKU. So hopefully that's going to give us a certificate. So we can also have a look on the web server template. We can see that basically, if you maximize that, try to do an authentication there. and we're using LDAP start TLS. So we're using the certificate. It let us actually inject administrator UPN. And we'll see if what happened here was that the KDC said that, okay, you have a certificate and you say that you are the administrator of the forest, and you also injected the client authentication EKU. So we're going to accept that, and that actually worked and added a user to the domain admin group. So you need to control all the templates that allow supply and request. This is really, really bad. So going back, so strong certificate binding enforcement. This has been around since 2002, and Microsoft is constantly moving the dates when this is going to be strongly enforced. I think it's been moved like 4 times or something like that. But now they plan to enforce it on February the 11th, 2005, and they are going to allow you to roll back until September the 10th. So what does strong binding enforcement mean? It means that either you need to inject the SID has to be part of the certificate. And if you're running ADCS, that happens automatically. So if you have auto-enrollment to your computer, or you have auto-enrollment to, if you're doing PIV with the smart card or YubiKey, as long as you run ADCS, that Microsoft has patched that up for you. So, but I mean, if you have a lot of issued certificates already, maybe you have them with your physical access card or something, it will be very hard to maybe pick all those in and reissue all the certificates. So that's where you can use the alt security identities attribute instead and do a hard mapping on the serial and the issuer. But that's also something you have to do. If you don't do this before this is getting strongly enforced, then your authentication with certificate against Active Directory is no longer going to work. So this is something, if you haven't planned this now, then it's time to start to do that. Also, if you're, how many is running .x, 802.x authentication, either for your Wi-Fi or even wired? If you're using MPS as a radius proxy for that, MPS checks against anti-out, and it also checks the strong binding. So if you have that and haven't planned to actually re-enroll all the certificates to include the SID or do the mapping, then you need to hurry up to meet the requirements, otherwise it's going to actually stop working. So if we have a look how that works, so if we go to the CA and we actually enable this strong binding, not that one, that one, and we try to use exactly what we did. So we run this again, and we're trying to add something to domain admins again as administrator here. And that succeeded. That was strange. Yeah. Now we can see that it doesn't accept the credentials anymore. So,
Chris, do you want to just explain more or less what went wrong before,
yeah,
and why
absolutely.
it's not working?
So what was wrong? What went wrong was that I had actually tried my other demo that's coming next here, and what that demo does is that it actually injects the SID. So here is where a lot of people think that when they have enabled this strong certificate binding enforcement, that they are safe, that you can have templates that allow supply and request. But what you actually can do is that since it is supply and request, you can not only supply the subject, you can also supply the SID and become compliant with that. So let's get rid of this certificate again. And now actually run another script where you can see that I actually inject the SID extension for the administrator as well. So now let's try that again. And that is now working. And now we have the strong certificate binding enforcement enabled. So that is not going to save you from this kind of attacks. That was designed for something completely else. That was designed for that you could actually, on a computer account, if you were the owner in the DNS hostname, you could actually put in the hostname of a domain controller there and become the domain controller. So that is not going to save you against this kind of thing. So how can we actually mitigate these things? I would suggest that you actually set up 2 CAs. One enterprise CA that is trusted in NT-out, and you can only have templates published on that one that has build from Active Directory, that the information that is used to issue the certificate is coming from Active Directory. You cannot supply any information yourself, and you have that trusted in NT-out. Then you set up another issuing CA that's also enterprise CA and untrust it from NT-out. But every time you're going to renew this CA certificate or the key, it's going to automatically get back into NT-out. So there is a different way how you can handle that. There is a script that a very good friend of mine called Sörqvist has written that's called NT-out guard, where you can whitelist the certificates that you trust for NT-out. So if you forget this like 5 years ahead when you're gonna renew that CA certificate of issuing CA2, then it's actually gonna pull it out from NT-out because that is not whitelist. So have a look at that whitelisting script. There is other things you can do as well. There is a reg key that's called disable extension list. And what that does is that you can disable certain extensions to go into the certificate. So you can disable, first of all, that this CA cannot issue any certificate with the SID extension. So it's going to block that. And you can also block this app policy thing that I showed that allowed me to patch up the web server template with the client authentication EKU. So you can disable that. And I recommend that you do that on this CA2. There is another thing you can do as well is on the templates, there is an attribute that's called PKI enrollment flag. And you can set a value that I mentioned here in that flag that will also make sure that those templates can never have the SID in the certificates that they produce. So, can it get worse? Yes, it can. Authentication Mechanism Assurance, AMA, how many has even heard or even used this functionality? Cool. So this is something that's pretty good. Everything that's designed to do good can also be used to do evil, usually, which this actually can. So what does this do? This actually does that if you authenticate against AD with a certificate that is connected to an issuance policy, that issuance policy can be connected to a security group. So when you authenticate with certificate with smart card or YubiKey, you get an extra security group in your token. And that's very good because that means that you're completely resilient against pass the hash, for example. Because if someone will steal your anti-hash and log on with that, that will only produce an authentication with username and password, and they will not get this extra security group in their token. So this actually enforces that the authentication was done with certificate, and only then you get this extra security group. And in this example, that is connected to a group that's called Enterprise Admins, AMA, that's member of the real Enterprise Admins group. So only when you authenticate with certificate and the right certificate template, you become an Enterprise Admin in the forest. But there is a problem with this. What we found out was that, okay, if someone within this forest can write to the AltSec ID attribute just to any user, it doesn't have to be an admin or anything, it could be any user. What you can do then would be that you go to CA2 and say, okay, I want to issue a certificate. There is a certificate template that has to play in request. And if I insert E, then I put that certificate in AltSec ID and I go authenticate against the KDC, then I'm going to be domain admin or enterprise admin. So let's have a look at that. So here is where we actually specify that OID that is linked to enterprise admin. And this CA is not even trusted in NTL. That's not even a requirement. So let's pull out the certificate there. This poor user is only member of domain users. We're just using him as a victim because we're sitting in like service desk and we have the ability to write to this user's AltSec ID attribute. So what we're doing now is that we are inserting and mapping that certificate by its serial number and the issuer. So let's do that. So now that's uploaded. And since we have that certificate now, we can go and try to use this certificate to authenticate against the KDC. And this is just Rubius. I modified it slightly so it can pick up certificates from the certificate stores instead of specify a PFX file and have to write the password for it each time. You just happen to rename it to goose.exe as well. Yeah, I think you have to skip that. So, but basically what that should have done is that should have been running as when we authenticated that, running it as user, you should have been a member of enterprise admin. Yeah. And there is another way how you can do this, the same thing. And this is a little bit more worse actually. And it's that since Windows Server 2016, you have this attribute that's called MSDS key credential link. And MSDS key credential link was originally designed for Windows Hello for Business. But what we found out here as well was that you could actually put and trust a certificate inside MSDS key credential link as well. And if you're a local admin on a computer, the computer itself can write its own MSDS key credential link through the self-security principle. So that means if you're just local admin on one machine in the forest and you have this AMA configuration, you can trust that certificate and you can authenticate as the computer, and the computer will be enterprise admin basically. So we can see if we can get that working. So basically here is the same thing. The only thing that is different here is that I get in the UPN, I put the name of this machine. And the only thing I am here is I'm local admin on it. I specify the same OID. This CA, whoever is trusted in NT-out. So the first thing I need is I need to become the computer itself first. So let's start a CMD as admin and using psexec just to start a CMD. And we can see that I'm basically empty authority system. And from here, I will use a tool that's called Whisker. And Whisker is a tool that actually writes the public key into the MSDS key credential link attribute. that doesn't work. It's something wrong with the KDC here. Not sure actually what it is, but what that should have done is that we should have got a Kerberos ticket for the computer itself, and with that authenticating with this AMA ID in the certificate, we would have been able to be added dynamically to the enterprise admins group. So how can you mitigate this? One thing you could do is that you could go ahead and untrust the CA specifically. So you can say that CA2 should be specifically untrusted on all the domain controllers. So you can just shoot out a group policy unblocking that, and this would not work because this doesn't rely on the CA being in NT-out. It's actually enough that the DC is just trusting the CA. So that's one way you can do it. And when you try to do this attack, and yeah, you still get the certificate, but when you try to present the certificate to the KDC, it's going to say that, oh, sorry, we don't trust that CA. So PKI unit is going to fail. So, but then someone figured out that, okay, but since it's an enterprise CA, issuing CA2 is member of a group that's called set publishers. And set publishers, if you're a member of that group, you can actually update your own CA certificate. So, and that would assume that you have your CA2 placed in tier 1. And this concept kind of falls, since you can do that, update the CA certificate with your own roost CA certificate, and you can then, of course, again, issue a certificate with that AMA ID in it, and you would be enterprise admin again. So the key takeaway here is that enterprise CAs must be managed from tier 0. The only way we found that you can actually block this is if you're on CA2, when you issue that CA certificate, you specify an assurance policy in that CA certificate, because that means that all leaf certificates needs to have that OID in them, and therefore they cannot have the AMA OID simultaneously. So they would actually block that. So you cannot put in your own policies if you do it that way. So did something similar exist in Entra ID? And yes, it does. There is something that's called certificate-based authentication in Entra ID. And there is an attribute or field that's called certificate user IDs, where you basically have the same thing, where you can actually point out a certificate that should be trusted for that security principle. And if you have that certificate, you can authenticate it as that user. So one thing that I did was that with logging on to an Entra ID tenant as a user administrator, and if I try to reset the password for a global administrator, Entra ID is just going to tell me, no, sorry, you cannot reset the password for global admin as a user admin. You don't have sufficient permissions to do that. So what I did was that, well, wait, what if I can update this attribute? So I pulled the certificate from the CA that was trusted from CBA, and it doesn't need to contain anything specific. So it could be any certificate from that CA. And then I put that in the global admin's certificate user IDs. And then I authenticated with that and become that global admin. So that's basically privilege escalation from the user admin role to global admin. And then I did decide to test something more, and that was to impersonate. If I invite a guest to my tenant, could I do the same kind of technique? So I invited someone to my tenant, and if I, again, even as a global admin, if I try to reset the password of someone from another tenant, that is not going to work. Entra ID is going to say, hey, are you stupid? You cannot reset the password for an account that comes from another tenant. But I could upload a certificate or trusted certificate. So I could actually authenticate and become someone from another tenant, but I could only use those credentials with my own tenant. I could not go to the home tenant with them. And I supplied this to MSRC, and they sort of confirmed, they confirmed that both ways were valid. So I got a Bounty Award for both of those, and Microsoft rolled out fixes for this globally. So those attack paths are no longer available. So that was it. Thank you so much for coming to this session. I'm really sorry that a few of the demos didn't work. Don't know why. I'm gonna find it out. I'm gonna post all the content, all the scripts that I used on my blog. I also want to do a shout out to the owners that have created the different tools that I've used, reviews, Whiskers, and also the certificate request tools from Carl Quist that I used to request the certificates during the demos. Thank you.
We do have a few minutes for questions. This is obviously amazing, deep, and it's totally acceptable that a demo doesn't work. I'm really happy that that first one worked, that we got an understanding that yes, you can influence certificates by injecting something into the template and whatnot. So those tips definitely need to be taken serious, because they are attack paths, and somebody can misuse them, and well, they own your tenant, they own your forest, whatever. Any questions for Christe?
Question.
Yeah.
Does on the CA, if it's only accessible through the web protocol, so you can't talk PKCS directly to the CA, but only using the web protocol?
Okay, so you mean if you blocked RPC and you can only talk to it?
Exactly.
Yeah, I mean, you could do it through the web enrollment as well.
Sorry, again?
Yeah. So you could, so that's possible. If you have supply and request on the template, you can do that through the using the web enrollment interfaces as well.
Okay.
Yeah.
Thanks.
So for web certificates,
Yep.
SANs are a thing, and you have to supply those in the request. If
Yeah.
you enable on the CA authority that it has to be approved by a CA manager, does this block that?
That's a really good question. So one thing could be that to have CA approval or a certificate manager approval, and then you have to actually review that it doesn't contain any of those things. But I mean, that could work for small company. If you have a large enterprise with a lot of certificate requests and you have to review all those manually, that maybe not be a good situation. But it also actually opens up another backdoor, because if you are, or if something are a certificate manager has the possibility to modify the request while it's pending. So that's actually another attack path. So if you have delegated that to an enrollment agent, or you have some portal that issues certificates, that account will also be able to actually modify the request and insert the OID for AMA to have another assurance policy.
So how would you suggest accommodating the need for SANs on web certificates?
To have them on a CA that's not trusted in anti-out, and make sure that you actually, on that CA certificate, you also have like your own assurance policy. You can call it like low TLS assurance policy or something, because when you have that, you block that, because every leaf certificate that comes from that CA need to have that in there, and it will block anyone else to put something else in there.
So I'd have to reissue the issuing CA cert for one of my existing CAs, or stand up a new one.
Yeah, or you could block it. The other thing that I showed, that you could block it on all the domain controllers manually and say, okay, we only trust this CA for web server authentication. It's never going to be trust for authentication against Active Directory. So that's another way of doing it.